Okay, here we have the basic setup of the light with the slit card, which narrows the beam of light, and a placement for the mirror so that light can reflect off the mirror. The mirror will be showing us the light reflecting off while it's plane, concave, and convex. And let's take a look at that at a bird's eye view. So here at the bird's eye view, you can see the light coming through the slit card, which is narrowing the beam of light. The mirror will be placed on the mirror line, and you can see that path of reflected light now is coming off the mirror. That's the light that we see that goes to our eyes. And we're going to look at how when we bend the mirror to be concave, the angle of reflection, that reflected light, actually gets smaller, closer to the normal line, which is going to give us a smaller field of vision and make everything in it look larger. And when we make the mirror convex, watch that path of reflected light is going to diverge, move farther away from the normal line, giving us a larger field of vision and making things in it look smaller. In a moment, we're actually going to measure the distance that the path of incoming light is from the normal line. We'll call that the angle of incidence. We're also going to measure the path of reflected light, how far it is away from the normal line, and call that the angle of reflection. We'll trace it with different colored pencils and then measure the angles after we create our normal line. Okay, to take a look at these angles, I'm going to first place a mark with a black pencil where the incoming light is coming through the slit card, and I'll make a mark where it hits the mirror. Next, I'm going to place the mirror onto the spot, and using a colored pencil, I'm going to mark where the light's coming off when the mirror is plane. I did that with green. I'm now going to make the mirror concave, and you'll see that the light comes a lot closer to the normal line. I'll mark that in orange. Finally, I'll use a third color and I'll make the mirror convex. And you'll see the path of light going farther away from the normal line. I marked that in purple. Now we can take away the slit card, get some light on this, and see our marks that we made. Here is our path of light coming in, hitting the mirror, and then reflecting off at a plane mirror, a concave mirror, and a convex mirror. Using a straight edge, I'm going to connect my incoming light dot to where the light hit the mirror. That's my path of incoming light. Using the green, I'll mark where the light reflected off the plane mirror. That's my path of reflected light for a plane mirror. Next, I'm going to draw in the normal line that we'll be using to measure the angles of reflected light, how far they are away from the normal line. The normal line is our 90-degree mark. And there, the dotted line is our normal line, our 90-degree line. We're now going to measure how many degrees the paths of light are from the normal line. The angle created when light comes into a mirror is called the angle of incidence. This is the distance from the normal line to that path of incoming light. Once light reflects off a mirror, a second angle is created. It's called the angle of reflection. That's the distance this reflected path of light is from the normal line. Using the protractor, we can measure the angle of incidence. That's the distance the incoming light is from the normal line. And I'm measuring here 16 degrees. The angle of incidence is 16 degrees. I'll again put the protractor on in the opposite direction to measure the angle of reflection. And you can see that for the plane mirror, 10, 15, 16 degrees. That means on a plane mirror, the angle of incidence and the angle of reflection are equal. The fact that light is reflecting off to the opposite side of the normal line will give us a reversed image. The fact that these angles are equal will give us a reflection that is considered normal or regular with no distortion. Now let's connect the path of reflected light for the concave mirror. It's clearly visible that the path of reflected light is closer to the normal line for a concave mirror than it was for a plane mirror. Still, we'll measure the angle of reflection. The angle of incidence is still 16 degrees, but the light now reflected off at only 5 degrees from the normal line. For the concave, 16 degrees for the plane. And now we'll connect the line for the convex mirror. Clearly the light rays diverged with the convex mirror. And the distance is 41 degrees from the normal line. 41 degrees for the convex. That would be a larger field of vision, and objects in it will look smaller. So now with this data, we can fill in our data chart for trial 1 for the plane mirror. Angle of incidence was 16 degrees. And the angle of reflection was also 16 degrees. For the concave mirror, the angle of incidence was 16 degrees, but the angle of reflection was only 5 degrees. Finally, with the convex, our angle of incidence was 16 degrees, and the angle of reflection, 41 degrees. So as you can see from the data, when light's reflecting on a plane mirror, the angles at which it comes into the mirror and reflects off the mirror are equal. Think about what that would do to the reflection you see. With a concave mirror, the angle of incidence is not equal to the angle of reflection. The angle of reflection decreased by 11 degrees. Think about what that would do to your field of vision and to the image seen. Finally, the convex mirror, angle of incidence was 16 degrees, but reflected off at 41 degrees, a 25-degree increase. Think about what that would do to the field of vision and ultimately to the image seen. Now let's take a look at trial 2. I ran the experiment a second time, On trial 2, the angle of incidence was 25 degrees for the plane mirror and 25 degrees for the angle of reflection. So again, the angle of incidence and the angle of reflection on a plane mirror are equal. For the concave, the angle of incidence was again 25 degrees, but reflected off at only 15 degrees. It decreased by 10 degrees. The angle of incidence for the convex mirror was 25 degrees and reflected off at 38 degrees, an increase in 13 degrees. Let's look at trial 3. In trial 3, the angle of incidence was 44 degrees. And on the plane mirror, the angle of reflection was also 44 degrees. For the concave mirror, although the light came in at 44 degrees, it reflected off at only 20 degrees. And when I bent the mirror to be convex, and I really bent the mirror this time, the 44 degrees that it came in reflected off at 68 degrees. So in looking at all this data that you should now have in your data chart, think about how these angles, whether they're equal or unequal, would affect the reflection that you see. Did the field of vision increase as the degrees increased? And if so, what did that do to the reflection? And vice versa. Think about this as you write your conclusion.